All right, guys, welcome to Async for today. I'm just doing this at the bottom. I added a few new pictures of our last set of notes. So if you missed class yesterday, you can come in here and check the notes out and read some of it. But I'm just doing this down here. I added some pictures at the bottom of it, so you'll get a new file. So a few last-minute things to note about least squares regression. First of these is the standard deviation. The standard deviation of the residuals. Standard deviation of the residuals, which is calculated using this formula. And what's really important is that we know how to interpret it, not necessarily determine it. So we look at the Ford here. Excuse me. Our example with the Ford F-150s from before, and we get that the standard deviation of the residuals is $5,740. And this interpretation is the important bit. The standard deviation of the residuals tells us, Nilla's staring at me right now. Hi, Nilla. It's the size of the typical residual. So it tells us the typical distance from a data point to our line is the size of a typical residual. So we have that. We can interpret this as the actual price is roughly $5,740 from the predicted price. And that's how we interpret the standard deviation of a residual. Okay? And if you look at the residual plot, which we've done a few times, you'll see this is fairly reasonable. Okay? And here's kind of the last bit of important information for a regression plot. And it's something that we've done a few times. Well, no, we haven't done it yet, but it's good that we could do it in the calculator. We've done it in the calculator before because it comes out when we get our regression line and when we get our R. It's the coefficient of determination, or the R squared value. And you do need to know that this is the coefficient of determination. You can't just know it as R squared. All right? And this like definition, if you read it, looks really scary. It looks really scary. It's like a lot of words going on there. But if we look at it in terms of an example here, we calculate R squared is 0.66. It tells us the sum of the square of the residuals has been reduced by 0.66. And here's, we don't really have it here. That's okay. What we could say is, one way to interpret this is the R squared value. This tells us that 66% of the variability is determined by, in this case, the miles driven. All right, so 66% from here of the variability in the data, so of the of how the data changes, can be is determined by the x value, the explanatory variable. All right, so R squared tells us the percentage of variability, which is determined by the explanatory variable, by the x variable. Right, and that's the important thing. Okay. Hope that makes sense. Here we go. This is how to make a residual plot. Told you we had to do it in the calculator. There it is. And we have some questions for you to do here. So for your assignment today, I'd like you to do this question here. This question here. Right, and we can interpret now as well. I'd like you to do 51. I'd like you to do 70. I'd like you to do 52. Oh, sorry, yeah, 68. And this is all of this problem as well. Okay, so if you do those problems, we'll be good to go.